Bonjour, welcome to Wahsa Citizens Education Center's Radio Zoom classes. This is MBF3C, grade 11 college math, and I'm the teacher, Bronwyn Slade. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You're always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday from 2 till 3 in the afternoon, and we are in our first week of our 9-week course. Just so you know what to submit for marking when it comes to that time, the support questions, the ones with the little pencil icon, are not for marking. You decide which ones and how many to do. You know what is best for yourself. If you're understanding a concept, feel free to skip questions. Though if you need more practice, you're also welcome to ask me for more practice, and I'm happy to provide you with some. The answers are in the back of your booklet, so check your work when you're doing the support questions to make sure you're on the right track. The key questions, the ones with the little key icon, are the ones to submit for marking. So please do all of these questions. I'm marking all of them, so please do them all and show all of your work, your steps, and your thinking. This way, I will understand what it is that you understand, and if you're struggling with something, I have a better chance of actually understanding what it is that you're struggling so I can help you out with it. If you only give me your final answer, you're only going to get either right or wrong, and therefore you can't get part marks if you make a mistake along the way. So how do you actually submit your work for marking? There's 3 methods. The first method is to scan your work and send it in electronically. You can scan your completed work using a device. If you have an Apple device, you can use the Notes app. And if you have an Android device, you can use the Google Drive app. Both these apps are free and generally come with these devices, though you can just download them if you need to. They have a fairly straightforward point and click scanning process, and I've linked in a tech tutorial video that you can just click on from the top right-hand corner of your screen if you're watching the YouTube replay, and then you can figure out how to do that if you'd like to learn how to scan. You can send pictures if you need to, though scanning just makes your files a little bit smaller and a little bit easier to send. Then send them either through email to studentwork@nnec.on.ca and CC it to Bronwyn Slate at nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to send it or drop it off in Sioux Lookout if you're in town. We have an outdoor mailbox at our location 74 Front Street at we're the bright red building next to the post office, and we have a small white mailbox next to our side entrance. The third method is to hand it into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. You can friend me on Facebook or subscribe to my YouTube channel, and then you'll get notifications every time I upload one of our videos. All of our Radio Zoom classes are recorded, and I post them to YouTube within 24 hours of airing. So everything is there for you to find. Also, there are short videos that explain common errors or confusing concepts that are in on my channel as well. And there's also tech tutorials that explain different tech things that you might need help with. Math is a really visual subject, so I strongly encourage you to access the videos. If you don't have reliable internet and you can't either join me live through Zoom or access the YouTube videos, that's understandable. We all struggle with internet sometimes. Just let me know, and I'm happy to send you a copy of the recording so you get the full experience and you really can set yourself up for the most success. If you have any questions or concerns, please reach out and contact me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is bslatewasa. You can call me at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m. Though I teach the last hour of my day, so that's not a great time to get a hold of me. Today we are diving into lesson 2, which is polynomials and factoring. This is going to be a 2-part lesson, so a 2-video lesson. So we're going to do the first half in today's video, and then in our next lesson, we will wrap up lesson 2, just to give you the heads up. So our learning goals for this lesson is that at the end of this lesson, you will understand and implement the distributive law, and you'll be able to factor trinomials. So you know you've met the learning goals because you can explain and identify polynomial terminology, you can multiply binomials, and you can common factor and factor trinomials when a is equal to 1. It's okay if none of that makes any sense. That's what we're learning today. So you might be asking, when are you actually going to use this in real life? Well, we are building patience and frustration tolerance. So this might not be, many of our content is not necessarily directly applicable to your life. You probably are not going to be factoring trinomials every day, but this stuff can be frustrating and can be challenging. And so building the skill to work through something, even when it is hard and struggle through, is an incredibly important skill that definitely will show up in your life somewhere. But first, let's activate our brains with some mental math. I am not a supporter of Mad Math Minutes. They cause stress and anxiety in students and generally don't actually teach students anything. So instead, we work on the approach of using strategies that are applicable in various situations and use friendly numbers and things that are comfortable for ourselves. So our question today is 8 times 21. I was a student who was really good at memorizing my multiplication facts, but as soon as I got past 12, because I was told to memorize up to my 12 times tables, I had no tools. I couldn't figure out what to do after that. And that really didn't set myself up for success in the long run. But since elementary school, I have learned that there are strategies that you can implement that use the facts that I do know. So for here, when I'm doing 8 times 21, definitely not a fact that I was taught or told to memorize, but 8 times 21 is the same as 8 times 20 plus 8 times 1. And I know what those two things are. So 8 times 20, well, not 20 wasn't a fact that I need to memorize, but 2 was. So 8 times 2 is 16. So 8 times 20 is going to be 160. And 8 times 1 is 8. So if I add those two together, I get 168. So 8 times 21 is 168 by doing the concept of partial products, where I break my number up into parts so that I can add them together. And this is something we're going to be continuing to use throughout today, this kind of idea. All right, first, mine's on. What do we need to know? We are going to use the area model of multiplication, which may be something that you were introduced to. It was definitely, again, not something that I was taught in elementary school. So we're going to go over it to make it hopefully make sense, because it's going to help us understand things when we are using variables and not just numbers. So we're first going to do this with numbers to help us make sense of what I'm talking about. So our example is 3 times 4. So this is the idea that we have 3 groups of 4 things. So we can organize our information such that we have 3 groups of 4 things. I have unicorns on my screen because who doesn't need unicorns in their life every once in a while? And this means, so this also, the other thing is that we could also say that we have 3 things in 4 groups. Multiplication is what's called commutative, which means that we can reverse it. So we could have 4 groups of 3 things, and either way, we have 12. If we have 3 groups of 4 things, we have 12 unicorns in total. And if we have 4 groups of 3 unicorns, then we have 12 unicorns in total. We can switch it around. The order does not matter when we are just straight up multiplying. So that's important to know whenever we're working through these things today. So returning back to the area model is if it's just a way to organize our unicorns or our things. So I have rearranged my unicorns, my 12 unicorns, into 3 rows of 4 unicorns each. So the length times my width is, so I have my 3 times 4 is like my length times my width. It's like I'm talking about the area that this is covering. And that gives me 12 unicorns because 3 times 4 is 12. So this idea of the area model is that if I organize things in this rows and columns, is that I can then just sort of think about them like I'm talking about the area where we're multiplying length times width. Let's look at another example, 5 times 9. So here if we have 5 times 9, if I have 5 as my length and 9 as my width, again, remember, it doesn't matter which order I do this in, but we're just going to go with this direction. This is the same as if I have 5 times 1 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 times 1. I don't know if I said that 9 times. So that is, if we just count by 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45. That is going to total up as 45. I also could count, we could break this up like we did in our mental math thing at the beginning, is that we could say that this is 5 times 3 plus 3 plus 3. So we could say that we could count by 5 groups of 3 times. So 5 times 3 is 15. So 15, 30, 45. We could be counting up by groups of 15. Or we could even do it in another, where they're not always the same thing. We could do 5 times 9 is the same as 5 times 5 plus 5 times 4. So this 5 times 5 is 25 plus 5 times 4, which is 20, which is a total of 45. So there's various ways we can do this, break these numbers up in terms of getting our total answer of 45. So then if we even have bigger numbers, so I have 17 times 23, and again, I'm going to organize my information where I have 17 long and 23 wide. And I can break these up into friendly numbers. So I can break my 17 up into 7 plus 10, and my 23 into 10 plus 10 plus 3. So that means that now I'm just going to multiply in the groups that are friendly to me. So I'm going to do 10 times 10, which is 100 unicorns or 100 things. And then I have another group of 10 times 10. So that is another 100 unicorns. And then I have 10 times 3, which is 30 unicorns. So I'm just going to write them on top, which is not beautiful, but then I do 7 times 10, which is 70 unicorns. Another 7 times 10, which is another 70 unicorns. And then 7 times 30, which is 21 unicorns. Sorry, 7 times 3, which is 21 unicorns. So I can organize my information in this way such that it's easy to break it up into groups that I can now add them all up. So I can add up my 100 plus 100 plus 30 plus 70 plus 70 plus 21. So 100 plus 100 is going to be 200. And 30 plus 70 is going to be another 100, so 300. Plus 70 is 370, plus 21 is 391. So 17 times 23 is 391. And this breaking it up into these blocks, into these groups of friendly numbers, makes it really much more accessible to do this. All right, so how does that help us in our new active learning today? It is something that we're going to be getting to, but first we're going to look at some vocabulary. So first we want to make sure that we're all talking about the same words so that we know what we're talking about. Variable is a really key one when we're doing throughout this course. A variable is a letter that represents an unknown value. It's an unknown number. We don't know how much it is. And so we're replacing it with a letter because it could mean various numbers. That's why it's variable, because it changes. A term is a number or the product of a number and one or more variables raised to exponents. We're going to look into more what that means with an example. Coefficient is a number multiplied by a variable, including the invisible one. Sometimes we just have a coefficient of 1, and if so, it doesn't look like we have a coefficient because there's no number in front of our variable. And a constant is a number with no variable. So a term could be a number and a variable, or two variables or more variables multiplied together. And the constant is when you don't have any variable, it's just a number. And then the degree is the highest exponent in your expression. So let's look at some examples with that. So our example is 7x to the 5th plus x squared y squared minus 4xy plus 7. Okay, so there are 4 terms. 7x to the 5th is one term. X squared y squared is a second term. Negative 4y, xy is a third term. And 7 is a fourth term. Basically, our terms are separated by either addition or subtraction signs. The coefficient of term 7, 5x is 7. That's the number that's in front. The coefficient of x squared y squared is 1 because there's an invisible 1 in front. The coefficient of negative 4xy is negative 4. And then 7 is a constant term. It doesn't have a variable, so it's not a coefficient. It's just a constant. Then the degree of this expression is 5 because 5 is the highest exponent. So in all of our terms, if we look at all of the exponents, 5 is the highest one that we have. When there isn't an exponent, that means that it's exponent of 1. But again, we're lazy, so we don't write it down. So 5 is the degree of this expression. So then, what is a polynomial? Polynomials are terms that have variables with whole number exponents. So negative 10 a to the 5th is a polynomial because the variable has an exponent of 5. 2x to the negative 3 is not a polynomial because the variable has a negative exponent. That negative 3 in the exponent makes it not be a polynomial. And 4 over t squared is not a polynomial because the variable is in the denominator. So polynomials are only when you have positive exponents that to your variable has a positive exponent of a number. So there's different types of polynomials. There's a monomial, which means you have one term. So 5a squared is a monomial, negative 3 is a monomial, 9x to the 4th y is a monomial. Those are 3 separate monomials. A binomial has 2 terms, like bicycle, 2 terms. So 6b to the fifth plus 2c to the third is one binomial. Another is 7y squared minus 12 is another binomial. And then a trinomial is when you have three terms. Tri like tricycle, three terms. So negative 15x cubed plus 2x squared minus 5 is a trinomial that has three separate terms. Then 2x squared minus 8xy plus 4x squared is also a trinomial. It has three separate terms. These things get more comfortable as you get used to them. We don't use the language too much, but it's just important that if I say these words, if they show up in your booklet, you know what they're talking about. All right, so now that we have some vocabulary under our belt, we're going to look at the distributive property. So this is on page 9 of your IL booklet. And we're going to use the example to start with of expanding 3 times x plus 4. A reminder that whenever something's in the brackets and there's a number or a variable right next outside the brackets, that this means multiplication. So using our area model, we're going to do 3, and we're going to think of 3 separate ones as our length, and then x plus 4 as our width, where we have x, and x, remember, is a variable. We don't know how big this is, so we're going to have a x term, an x rectangle that doesn't matter how long it is. This isn't equal to a number, certain number of ones. We don't know how many it is. Plus 4 ones. So 3 times x plus 4 is equal to, we're going to do our first step where we're going to do 3 times x, which is 3x, because now all of a sudden we have 3 x's. And then we do 3 times 4, where 3 times 4 is 12. So if we simplify that, we have 3x plus 12, and that's how we expand. So with the distributive property, it's really important to remember is that whatever you have on the outside of your expression, you need to multiply to both parts or all the parts that are inside your brackets in your expression. That is the distributive property. And that's all you need to know to do question 1 on page 11. So then the distributive property with 2 binomials, this is when it starts to get a little bit trickier. And this is on page 11 of your IL booklet. So we have x minus 5 times x plus 6. And so again, we're going to be using our area model. We're visualizing with what are called algebra tiles. I forgot to tell you that, which I will link into your in your show notes. There's a manipulative that you can go on virtually and you can actually play with these tiles, so you don't have to draw them all out if you want, if this helps you. So if x minus 5 is our one binomial, so we're going to do an x term and then 5 negative 1 terms, and then times x plus 6 means that we are doing x, 1x, and then 6 positive 1s. So x times x, if we look at our visual, we can see that x times x, if we have an x as a one length and x as the other length, we're going to end up with an x squared as our area. Then we have, so that's x times x is x squared. Then we have x times positive 6, and that's going to be 6x. X times positive 6 is 6x. Then we have x times negative 5, or negative 5 times x. Remember, the order doesn't matter. So negative x times 5 is negative 5x. And then negative 5 times negative 6 is negative 30 total. So remember that a negative times a positive is a negative. This is something that people make a mistake with all the time. If you need some practice or some review about multiplying with negatives, there are some videos on my YouTube channel you can check out. So now we have x squared plus 6x minus 5x minus 30. And now we want to simplify this, and we want to, because we have some positive x's and some negative x's, and they can cancel each other out. So how we do that is we think about them as just one positive x and one negative x together creates 0. They cancel each other out. And so we go through and we cancel out all of the x's that we can, the positive and the negative x's that we can, and we are left with 1x, because 6x take away 5x is going to give us 1x. So we end up with x squared plus x minus 30. You could also put x squared plus 1x minus 30. That would be fine. But mathematicians are lazy, and we try not to write extra things if we don't have to, so we don't put the 1 in. And that's how you multiply two binomials, how you do the distributive property using algebra tiles. It is key to remember that you can only add or subtract like terms. Like terms have the same variables, the variables having matching exponents. So here we have x squared plus x. We cannot add them together because they do not look the same. If we look at our picture, right, we have an x squared, which is a big square block, and we have an x, which is a long rectangle. We cannot say that we have two of those, right? Because they are different shapes. They do not match. So we cannot add them together. The positive and the negative x's we could combine because they're the same shape. They cancel each other off. But an x squared term and an x term are not the same. They don't look the same. We can't combine them. The same way with x and all of these negative 30 ones, right? They're not the same shape. We cannot cancel them off because they are not talking about the same thing. They are not like. So remembering the visual really helps in terms of remembering that you can only add and subtract like terms. If they are not the same shape, you can't add them together. If they do not have the same variables and same exponents, you cannot combine them. That doesn't work. All right, let's look at another example. We have negative y plus 3 times 2y minus 1. So putting that in our area model, we have a negative y and 3 positive ones, and we have 2 positive y's and a negative 1. As you can see, my y's are slightly different size than are my x's because they're not the same variable. We don't know what they are, but they're a different variable, so they're slightly different unknown. Then we're going to multiply it again. So we're going to have negative y times y is going to be negative y squared, and negative y times y is negative y squared. So if we do negative y times 2y, we have negative 2y squared. Then we have negative y times negative 1, which is positive y. We have positive 3 times 2y, which is positive 6y. And then we have positive 3 times negative 1, which is negative 3. Then here for this one, when we're combining our like terms, we don't have any like terms to the y squared, right? We just have negative 2y squared. We have now, if we look at our diagram, we have 6 plus 1 y's. Those are all the same shapes, so we can combine them. So we have 7y, and then we have 3 negative 1's, so we have negative 3 at the end. And again, we have multiplied those two binomials. So here is the Polypad is the virtual manipulative that you can use. I thought I had it linked in here, but I guess I don't. Here, let's see. We can just quickly go and you can see it. So this is, I will link again. I will link again into this, but algebra tiles are what we're using. And so you can see we have all of these tiles that you can then put and multiply. If you want, you can change them to be positive or negative. And if you want to use them, you can. They snap into grids, which can make your life a little bit easier. It's a pretty friendly tool if you want to check it out. And again, I will link that into your show notes so that you can then check it out and see it from there. Oh, this one should be negative. So there is just a quick showing of that virtual manipulative so that you can do it on Algebra Tiles. Now, not everybody, if you were in a classroom, we would have actual Algebra Tiles that you could move around. Most folks don't have that. So, and drawing out all of these little rectangles and squares gets tedious after a while. So you can also do this just with numbers. So you can write out the same thing. So where you have this little sort of kind of like a T graph, but a little bit different. And you have your negative y plus 3. So the same way that we had our Algebra Tiles negative y plus 1, 3 ones, we have negative y plus 3. And then we have 2y plus, plus minus 1. And then you're just going to draw a box. This is called the box method. So you're going to draw a box between all of your terms, lines between all your terms, so that you end up with these little boxes that represent these areas that we'll be multiplying. So negative y times 2y is negative 2y squared, which matches our visual. Negative y times negative 1 is positive y, which matches our visual. Negative 3 times, positive 3, I don't know why I want to say that negative. Positive 3 times 2y is positive 6y, and positive 3 times negative 1 is negative 3. So you can use this box method instead of the Algebra Tiles to write out your multiplication, and then you can organize it to combine your like terms. So both these options are great. The Algebra Tiles or box method are both really good in terms of if you need to do it visually, organizing your information. There is another method called the FOIL method, which is what your booklet goes through and what you may have heard in other times, but I'm not going to spend time on that because you most likely are familiar with it, and it's not my favorite way. So I want to introduce some other methods that work great. Okay, so if we have the distributive property with 1 monomial and 2 binomials, so that looks like this, where we have 3 times x plus 7 times x plus 4. So we have one monomial, one term, times x plus 7, which has 2 terms, and x plus 4, which has 2 terms. So 1 monomial times 2 binomials. So most often, people want to do this, where they take their 3, their monomial, and they multiply it by every single one of your terms. That's what people want to do. And that's really confusing. So we're going to look at a simpler example to see why that is incorrect, because this is something that is really makes people make this mistake all of the time. So we're just going to look at with numbers. We're going to do 8 times 5 times 2. So remember, numbers next to the brackets mean, or brackets next to brackets means to multiply. So we're going to do what people usually would do is 8 times 5 plus 8 times 2. That's what that's the same thing as where if you're multiplying the monomial by every single term. So that's 40 plus 16, right? 8 times 5 is 40, 8 times 2 is 16. So 40 plus 16 is 56. But this is not right. What you've actually done is that you've done 8 times 5 plus 2, which is 7. You've done 8 times 7. You have not done 8 times 5 times 2. So the same way, you don't want to do that monomial by every single term. So don't do that. You're going to be, you're probably going to want to do it because you're not going to be thinking about it, but it's important not to do that because you're multiplying too much. So instead, if we look back at our simpler example, where we have 8 times 5 times 2, really we want to do just like I'm saying it, 8 times 5 times 2. So first we do 8 times 5, which is 40, and then we're going to do 40 times 2. 40 times 2 is 80. And that is the correct way to multiply when you have 3 terms that you're multiplying like this. Not multiplying one by both of them. That's like if you're adding those other two, we want to multiply one by one and multiply the answer of that by the other one. So let's look at our complicated example again of 3 times x plus 7 times x plus 4. Now there's 2 different ways that you can do this. So looking at method 1, first you do 3 times x plus 7. So you're going to do this first multiplication part using our box method. So 3 times x is 3x. 3 times positive 7 is positive 21. So that's our first step. So then if we're writing it out, we're going to write 3. So now that we multiply 3 by x and 3 by 7, we're going to do 3x plus 21 in our first set of brackets times x plus 4. We've done this multiplication first, just like when we did the 8 times 5 and we got 40. We've done that multiplication first, and now that's our new part that we're going to be multiplying by the second binomial. So then we do 3x plus 21 times x plus 4. Again, we're going to use our box method. So 3x plus 21, x plus 4. So 3x times x is 3x squared. 3x times 4 is positive 12x. Positive 21 times x is positive 21x. And positive 21 times 4 is 84. So then we can, in our next line, in our next line, we have 3x squared plus 21x plus 3x squared plus 12x plus 21x plus 84. And then we're going to combine our like terms. Our x's are only like terms, so we're just going to combine those. And we get 3x squared plus 33x plus 84. And that's how we multiply a monomial times 2 binomials, is that we can do the monomial times the binomial first, and then our new binomial times our other binomial. The second method to do this is to multiply our 2 binomials first. So we can do x plus 7 times x plus 4. Using our box method, we have x times x is equal to x squared. X times positive 4 is positive 4x. X times positive 7 is positive 7x. And positive 7 times positive 4 is positive 27. So then if we were to write that out, we would then write 3 times, in brackets, x squared plus 4x plus 7x plus 28. Then combining our like terms, we have 3 times x squared plus 11x plus 28. So now I'm going to do 3 times x squared plus 11x plus 28. So everything, I'm going to multiply 3 times everything that's inside of my brackets. So 3 times x squared is 3x squared. 3 times 11x is positive 33x. And 3 times 28 is positive 84. And so then that is our final answer, which if we think back was the same thing that we got in our previous method. So you choose the best tool that it is for you. Both if you're doing a monomial times 2 binomials, you can do either method 1 or method 2, you'll get to the same place if you do it accurately, whatever makes sense. If you want to use algebra tiles, go for it. Use algebra tiles. If you want to draw them, you can totally draw them. It doesn't have to be beautiful. If you want to use the virtual manipulative, use it online. There's also an app, which again, I will share in our show notes so that you can check out. It's a free app you can download if you want to. Using the box method is my favorite method, as it is concise and clear for me to write down. Or you could use the FOIL method, which I didn't teach, but as I said, you may be familiar with from learning it in grade 10 from another teacher. And it is what the IEL booklet goes through, which is first, outside, inside, last. I don't love it because it's just a matter of memorizing the steps opposed to understanding what's actually going on. And now you are able to do the support questions on page 13, questions 2 through 5. All right, so let's consolidate what we have done today. So we've started lesson 2. We've focused on the polynomials part of this lesson. So first we went over the polynomial vocabulary. So you need to make sure that you're comfortable using the terms variable, term, coefficient, constant, and degree. You also know the difference between a polynomial, monomial, binomial, and trinomial. A polynomial, I don't know if I actually defined. It has many terms. That's what poly stands for, many. Then we looked at the distributive law, so expanding using distributive law, where we multiply each term inside the brackets by the term outside the brackets. We have one monomial with a binomial. That's how we would do it, or a trinomial. And then we talked about expanding and simplifying binomials using the distributive law, where if we could use algebra tiles, the box method, or FOIL were all tools that we could use. So hopefully now you are comfortable with you can meet the success criteria. You can explain and identify polynomial terminology, and you can also multiply binomials. So let's do a few practice problems. So for each polynomial, identify the following: the type, degree, constants, terms, and coefficients. So for this A, we have negative 12a to the 6th plus 15a to the 5th minus 8a to the 4th minus 2a to the 3rd plus a squared minus a plus 32. Sorry, I made a ridiculous one. So the type, so this is a polynomial. It does not have one term, two terms, or three terms, so it has many terms. So it is just a polynomial that we don't need to specify it any further than that. I believe it has 7 terms. 1, 2, 3, 4, 5, 6, 7. So it has 7 terms. The degree, what is the highest variable? The highest variable is 6. So it has a degree of 6. Often we write these in the order such that from left to right, from the highest variable, or sorry, the highest exponent to the lowest exponent. That isn't a guarantee. So look out for that. So then the coefficients. Are negative 12, positive 15, negative 8, negative 2, positive 1, negative 1, and then the constant is 32. In terms, I guess I probably should have actually listed them. So negative 12, 6, 15a to the 5th, negative 8a to the 4th, negative 2a to the 3rd, positive a squared, negative a, and 32 are my 7 terms. All right, we are not going to do this other one just for the sake of time, but this one only has 3 terms, so it's a trinomial. All right, so number 3, expand and simplify negative times 4x minus 11. So this has this invisible 1 here just to help confuse you. So I'm going to use the box method because it's my favorite. So negative 1 times 4x minus 11. So negative 1 times 4x is going to be negative 4x, and negative 1 times negative 11 is going to be positive 11. So this is going to be equal to negative 4x plus 11. Number 4, expand and simplify 4y minus y squared times 3y minus 1. So this is a tricky one, just listening to me, because when I said minus, I should have said open a bracket, y plus 2, close a bracket, then times 3y minus 1, close a bracket. It's hard. It's easier to see. This is why it's really important to watch the videos and not just listen, because how we read it and how we see it are slightly different. So this is tricky because we have that invisible 1 in here again, right? So we need to make sure that we multiply that invisible 1 by both terms in our first binomial, but that we don't multiply that again by our second binomial. So I am going to there's, again, 2 different ways to do this. It's probably better to do it like this, where we're going to multiply our 2 binomials together. So using the box method. So y plus 2 times 3y minus 1. So we have y times 3y, which is 3y squared, y times -1, which is -y, 3y times 2, which is 6y, and 2 times -1, which is -2. So I'm still gonna have 4y minus, because I haven't done anything with that. And then I'm gonna have my 3y squared minus y plus 6y minus 2 all inside my brackets. So I'm going to simplify my like terms inside my brackets. So 3y squared minus y plus y squared. So 3y squared stays the same. Minus y plus 6y is going to be plus 5y. Minus 2 stays the same. So now I have to remember that I have to apply this negative sign to each of my terms inside. So I'm going to do -1 times 3y squared. So that's going to be -3y. And then I'm going to do -1 times 5y, which is -5y. And then we do -1 times -2, which is going to be +2. So these questions can be tricky because you have to make sure you're applying that negative to each of the terms inside the brackets. Now I'm going to rearrange my terms, and so that I can simplify it and combine like terms. Here, when I had 4y at the beginning, that was plus 4y. So we have -3y squared plus 4y minus 4y. So that's going to be minus 1y plus 2. And now I don't have any more like terms, and I can't simplify anything further. And that's how we do that kind of question. It's a little bit tricky, so you want to just be paying really close attention to what it is that you are doing. Number 5, write a simplified expression for the area of the object below. So we have a rectangle that has one length side is 8x, and the other side is x plus 5. So the area of a rectangle is equal to the length times the width. So that is equal to 8x times x plus 5. So here we can think that we're going to do 8x times x. So that's going to be 8x squared, and then 8 times 5, which is going to be 40x. And that we don't have anything that we can combine any like terms. So that is the expression. That is all that we're going to do. The area is equal to 8x squared plus 40x. That is all that we can do. We can't do anything further for this question. All right, so that is wrapping up our lesson for today, for the first part of lesson 2. In our next class, we will wrap up the rest of lesson 2, but we will be looking at factoring. We are basically going backwards from what we were doing today. So it's really important to look at the second part of lesson 2 as well as this lesson to really understand it is quite different, though based on the same principles. If you have any questions, please reach out and contact me. You can call me at the office at 807-737-1488, extension 2209. You can call also toll free at 1-800-667-3703. You can email me at bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. You can connect with me through Facebook, where my name is B-Slate Wahsa. And remember, my YouTube channel will have this lesson as well as our previous lessons up. And that channel is also called B-Slate Wahsa. My office hours are Monday through Friday, 9 a.m. to 3 p.m., except on Thursdays when I'm in from 10:15 till 4:15. So please reach out if you'd like to connect. I'm happy to support you however I can. It is what I'm here to do. Thank you so much for joining me today. Miigwech.